consider renewable energy integration to any power system. Those are intermittent in nature, and due to which it is very, very difficult for any power system to predict the amount of energy which is available to me at a given point of time. And that makes your problem much more complicated during peak hours. First of all, you're operating during peak hours. You may have excess of 1% or maybe shortage of 1%. And during that time, the expected energy from the renewable energy integrated sources, if the load is not matching as desired with the generation, then probably the system is going to face a severe challenge. So when the PV output power in active distribution systems exceed the load demand, the system voltages rises and resulting in reverse power flow too. So what exactly happens in any system, if it is going to be a distributed system, if the feeder is going to be a radial one, and you have a lot of PV energy available during the terminal points, and if the consumers during that hour, if they're not drawing the PV power which is available to them in the next door, then those PV has to flow further back because no takers, and finally it will hit the PCC, point of common coupling, and then it will start reversing from a distribution system to transmission system. Okay, so I think it is also equally important not only having the renewable integrated systems, but also managing those energy properly, consuming them as early as possible to the nearest point become an important issue. So now as you could see from the diagram, because you could see the load curve, and we are experiencing actually two different peaks from the blue characteristic. We have the first peak, the blue load curve, and you have a second peak. However, the PV generation is available to you during the day hours. So during daytime, we have excess energy, and during evening hours, you have shortage of energy. So it is equally important that those PV energy or PV generated energy available to us during day hours need to be moved to the evening peak. How they can be moved, as I told you, either we can bring those customers to the PV dominant duration or store the PV generation in the form of a battery and try to discharge during load hours. So these are the two solutions available to me. And as you could see from a diagram, you can also experience reverse power flow. As you could see, there is a load point at the center. And if you're not consuming, then that is expected to flow to the main grid again. So that is another challenge. Means if I compare these two diagrams, both technically and philosophically, you do have PV generation during a time when the customers are limited, and hence that energy is not being consumed, and hence it is to go somewhere else, or you have to derate, which is not ethical practice for renewable energy, or indirectly you have to put some load. So for the right hand side diagram, what I will do to avoid reverse flow, I have to put some additional load. What is that additional load? Is nothing but a storage device, any form of storage. Okay, good. So with this philosophy, increased use of intermittent renewable energy sources and new types of mobile loads present operational challenges and severe threat to the network voltage regulation, as we have discussed. And when the PV output power in active distribution network exceeds the load demand, there will be a reverse power flow experience. When the load demands are high, there is little or no solar power supply, under voltage might be noticed in the active distribution network. Okay, so sometimes you have excess generation, voltage rise, under generation you will have voltage down. So this phenomena of over voltage during the afternoon hours and the under voltage due to the cloud transient and heavy loads at night is extremely common on college campuses. Okay, so just give me, a couple of minutes. I'll be back very soon. Yeah. Sorry about the interruption. So when the load demand are high, as you know that whenever there is excess energy, we will have over voltage, and whenever there is sort of energy, we'll have under voltage. So this phenomena of over voltage during the afternoon hours and under voltage due to cloud transient and heavy load at night is extremely common on any academic campuses. Okay, especially in academic campuses, this type of scenario become very, very common. So in this regard, EMS, that is energy management system, present in battery storage systems, BSS, has been proved to be an effective solution for. So what we are suggesting, we can have a battery which can be charged during excess PV or excess voltage situation. We can discharge it during peak, evening, or under voltage situations. Very good. So what is the advantage we'll gain? We'll gain voltage control because of this. Managing intermittent and stochastic power generation from PV. So if you directly connect to the load to the PV, then it is very difficult to match. This fellow is oscillating and that fellow is also oscillating, and matching become a challenge. But if you put a battery, then it constantly observes whatever it is, ABCD 60%, 70%, 90% charge, finally discharge as and when is a bulk. Am I right? So peak load saving is also possible. Minimizing power loss is also possible, and line load in distribution system is also can be balanced. So this energy management scheme provides an option to maintain the peak at a specific range, and at that same time provides various ancillary services. So the battery is not only applicable to manage your peak saving or during peak hours, and it is also important that it can exercise some of the ancillary supports in the system. So that is one important aspect of actually battery system. Now you all can have a look to the real-time analysis of distribution network with solar integration. We'll be talking about a single case study. So this is the IIT Roorkee network with many solar installation, almost close to 35 locations. And you could see it is a weekly mesh network we have two different 33/11 kV substations, 1 and 2, 33 kV bus, which is available, and you can see many switches. So the switches actually sometimes create a mess, and sometimes it create a radial also. So very few, I was talking to a couple of friends last week, and they were surprised to know that it's such an old system which is weakly messed. Because I was talking to a professor from IIT Madras, he said our system is purely radial only. I said no, ours is also radial, but we are having few switches actually to create some messes as and when given. So that way it is a very good system. Now, all of you please have a look. Real-time voltage variation with PV integration, and you could see there are three different actually phases: phase 1, phase 2, phase 3. And you can experience actually, the voltage profile of the system during actually spring, summer, and autumn. So during different weather conditions, the voltage profile, at different points have been taken. And could you see some spikes actually in somewhere at the edge? Okay, some voltage actually going beyond 1.05. Okay, a few times you could experience some over voltages. All right. And so overvoltage signifies high PV penetration with lightly loaded condition. When the load is low and the PV integration is more, then you experience increase in voltages beyond 5%. Absence of PV and high loading conditions lead to low voltages at some of the locations. You can see somewhere it is even below 1 per unit also. So for efficient utilization of available surplus PV power, deployment of BESS can be helpful. So what I wanted to highlight, any distribution system do experience excess actually voltages due to excess PV and under voltages due to excess loading conditions. So I think there is a solution that is possible through a proper uh, battery integration. Now, if you focus on real-time voltage variation with PV integration, this is at different hours actually. So you could see we have taken a 415 volt node shown for two extreme hours of each season after the battery integration. So what we wanted to highlight that if you put a battery and if you see the voltage profile, okay, I think the profile become more or less flatter because when you put a battery, the voltage profile is expected to be quite flat. So a linearized AC optimal power flow model is used to observe the effective 200 kilowatt hour battery installation at node number 9J2. That is how they have been numbered at the VIP substation. And voltage variation at all the nodes for 3 representative days of the season are shown in right-hand side figures. A reverse power flow is observed through the transformer T1 side connection. Requirement of more battery capacity is proposed and a MILP problem is formulated to determine the required battery capacity. Now, if you see the battery power and energy rating, so in the previous network that I have shown, so we have actually tried to determine how much of extra energy is required to manage the whole distribution system with a voltage profile close to 1. Okay. And then we determined that the power rating of 75, 50, 75, and 100 at 4 different locations, that is close to 300 kilowatt. Am I right? And the kilowatt hour, if you see, that is going to be 150 plus 100 plus 150, 400 and 200, 600. So 600 kilowatt hour and 300 power rating. So probably it will supply for 2 hours. Okay. The total energy will be used for 2 hours. And that is enough to create a wonderful voltage profile in the system. Now, before we put the battery, as I told you, I think we need to have a PHIL implementation. And that means we need to have a battery pack and then put that stack in, carry out the PHIL experimentation as like your wind generation, PV generation, whatever you have done, repeat it. And once you feel the whole distribution system is not going to experience any transient and the voltage profile is being properly maintained, and then you go to the field and then put put a physical battery in real time. Okay, so this is what the demonstration talks about, and this is what the distribution system is all about. So finally, we realized that okay, these are the locations actually the battery need to be installed. I told you the story about the financial challenges and issues associated. So we could not put all the batteries. So as of today, there are two batteries only with 272 capacity and 150 kilowatt hour. But we are operating the electrical department battery with 200 kilowatt hour for the safety and 150 for the old humanities building. So totally 350 kilowatt hour is currently in practice. So there are two scenarios that I like to highlight. Probably this is what quite interesting. All of you must concentrate here. Now, in this case, this is one of the microgrid that is available in the Department of Electrical Engineering. And you could see there is a lithium-ion battery, which is at the center. And our electrical engineering department has the access to the diesel generators. It has access to the rooftop solar. It has access to the main grid, and also it has access to the battery. So there are all four different type of sources available which can be catered to the department. So to me, the electrical engineering department of IIT Roorkee is considered to be one of the set example of microgrid. And as you could see that the rooftop solar is close to 170 kilowatt and the total load is going to be 111 kilowatt. So what happens, the PV energy that is being generated, almost how much? Close to 60 kilowatt every hour, which is available to me. And if it is fully operational, so then probably it is quite enough for me to charge the battery. But you will be surprised to know that I could have gone for further large size batteries even, isn't it? So instead of 200, probably even if I go up to 300, 350, 400 kilowatt hour, still I can accommodate the solar energy. But the solar energy during cloudy season and winter, we have excess winter actually in Roorkee. So most of the time actually we are not able to get as high as 100%. So probably it is 80 to 85% efficiency. So even if it is giving 150 or 140, so then I have 30 kilowatt actually excess, and almost for 7 to 8 hours, it is close to 200, close to 200 to 220 kilowatt hour. So my battery is efficiently working. All right. Very rarely actually we derate. Now, the very important part, so this is a microgrid that you have seen, and so we like to justify the role of battery in this case. So with this, we are coming to an end of, kind of the role of battery and how battery can be used for energy management or peak energy saving of any distribution system. I have been told that, I think most of the evening hours, evening peak, currently the 200 kilowatt hour is being discharged to the electrical engineering department without consuming the energy from the main grid as well as neither from the diesel generator. So what this microgrid is contributing, we have two microgrids, but this microgrid is indirectly not loading the 33 kV substation during peak hours. So this is what actually we like to highlight out of this activity. Now we can slowly come out to a conclusion remark of this course. So what exactly we have learned, what are the challenges, what are the difficulties, and the merits as well as future scope to be continued. So let us start a little bit before I conclude. India's journey in the field of smart grid. So it is not very old journey. It is almost 10 years plus. And as you could see, smart grid objectives in India, which has many dimensions. So first of all, industry collaboration with ESCO models, 3 full-scale projects of 258 crores on smart grid, 40,000 megawatt rooftop PV by 2022, and then efficient use of existing sources, proliferation of electric vehicles, which is an action, Smart cities, smart grids are in place, and 35 million installation happened in 2019. So if you see, there are different projects actually that Government of India has initiated, because now smart grid is very popular. But 2012 to 2014, when we started smart grid, there was no case study, there was no example. So even a smart meter installation, we look at it as a smart grid. Am I right? So that is how actually, that is the era actually where we started. So as you could see that Ministry of Power, Government of India approved, SG pilot projects actually. So there is an advanced metering infrastructure. So initial days, even putting AMIs at different substations or distribution systems are considered to be smart grid at that time. I mean, but today, putting a SCADA become a smart grid. And after a few days, until you have a ADMS, your system is no more smart. Okay. So power quality management programs, outage management systems, peak load management, and distributed generation installation, they are the component of different pilots that government has initiated in 2010 to 2012 as the initial steps of smart grid. So I thought it is good for all my listeners and student friends just to understand, because they are in this 2025 era now. They must know what exactly happened to this country, how we moved to smart grid pilots. So the pilot project actually cost approximately 3,800 million rupees being spent. Actually, one of the project is CESC Mysore, then actually UHBVN Haryana, Himachal Pradesh, Assam, Punjab, West Bengal, Tripura, Telangana, Pondicherry, Ajmer, Gujarat, and IIT Kanpur Smart City proposals are being the initial investments being brought from government to different pilots. Now, National Smart Grid Mission is also a body which has been constituted to channelize the smart grid activities of this country. So through which what they have decided, they have actually spent around 5,773 million rupees, and in which actually Chandigarh, Amravati, and Congress Nagar and Kanpur are part of those investments. Now there are many research projects that Government of India has sponsored. I'll be very happy to say that for the first time in the history, Indian government invested some money on smart grid, and this is the initiation in 2013-14. There are 5 projects. Each project is close to 5 crores. So around 25 crores have been invested. And as you could see, the one is going to be advanced communication and control for prevention of blackouts. Proposal name is actually accept. High energy and power density upward solutions for large energy deficit, reliable and efficient system for community energy solutions, rescues, and then intelligent microgrids with appropriate storage for energy, that is IMAS, reconfigurable distribution network. And these are the 5 proposals, and they have been initiated with collaboration to international UK and India collaboration projects. And you'll be very happy to see that the second proposal that you could see is my project, which is close to 4 CR R&D grant. So almost if you see the first R&D project on smart grid which has come to me, and probably that has motivated me to work further and continuously. So then we had some success stories to share. Pondicherry Smart Grid pilot project, jointly developed by Power Grid. So they try to have actually indigenization of technologies, common information sharing platform, and scalability and replicable to other cities, evolving policy advocacy, and evolution of commercial mechanism. Implemented functionalities, that is advanced metering infrastructure, demand side management, outage management system, renewable energy integration through net metering, and solar electric vehicle charging stations. So the cost was close to 461 million investment, and consumer base, which was close to 33,499. Then we had one more project, which is Chamundeshwari Electricity Supply Corporation Limited, Mysore. There also similar kind of power grid initiative was carried out with an investment of actually 325 million, and consumer benefited out of which is approximately 24,000 people. And the objective was actually AMI infrastructure, advanced metering systems to residential and industrial customers, outage management system, that is OMS, and peak load management through demand response program and distribution generation initiatives. What they have accomplished, if you see very closely, 18,000 single phase meter to be installed, installation of 446 DCUs, installation of three phase LTCT meters, agriculture DSM with community portal, KPI based MIS and data analytics for rural Karnataka. Then we had a IIT Kanpur smart city project, that is a smart city pilot in a power distribution sector, where it was expected that approximately 1.125 million rupees being invested to make the campus level smart grid. It's a Government of India power grid sponsored supporting systems. Now, key smart grid facts and figures till 2016, because now we have the data, but the old data is close to number of smart meters installed was close to 5.2 million. Number of electric vehicles were 6,000 at the time. So probably now it might have crossed, probably a few crores. Okay, number of automated substations were 4 at that time actually. Okay. So smart grid R&D areas. So many people ask actually what are the area I have to focus on and what are the topics I must focus. So operation, control and protection are considered to be important areas. So operation is my field, and control and protection are the field which is very important for smart grid. Okay, so operation, control and protection. Sure. And then when you will be asking that what about protection? So the protection will be aligned with the control scheme itself, all right? So operation and control of large, medium and small scale renewable energy sources, and protection techniques for AC/DC smart grid, wide area monitoring, protection and control, energy management techniques, supervisory control of network with multiple micro and nano grids, all right? Network analysis and optimal power flow, modeling and simulation of large power grids including cyber systems, seamless grid operation involving TSO and DSO, forecasting of renewables and loads. So these are the 10 important, 3 plus 3, 6, around 9 to 10 important topics, which are considered to be important R&D topics in 2020. But even today, these are the domains actually one can focus. Few more new areas which is not related to electrical engineering, but if someone has interest, probably can extend their work to this area, which is information communication technology and cyber security. So they are reliable wired and wireless communication technologies, interoperability and ICT architecture, audit and validation tools for cyber security features, and WAN and Internet of Things, threat models and cyber security, information privacy and handling challenges. Cloud computing, data storage, and big data analytics are the fields. There's also an area where actually converters is going to be an important area for R&D for smart grid technologies. So for right through enhancement of converter interface to renewable energy sources, especially those who belongs to polytronic side, can explore R&D in those areas. Grid interfacing and islanding issues along with seamless transfer technology, ancillary services of converters, optimal design of flexible power converters, coordination and control of multiple converters and modular multi-level converters, converter technologies for HVDC and MVDC systems. So device and technology were multifunctional hardware smart grid enablers, smart and unified control of converters, hot swappable converters for smart grid, standardization of voltage and power levels, network voltage regulation and power quality, wide band gap devices, that is GAN. Now, if you move to distributed energy resources, storage and deployment issues, policy, because there are a few things that we have not included, we are talking about technology, but until unless you have policy, regulatory and market design in place, none of your technology is going to work, all right? That is very important. Then demand side management with optimization and forecasting techniques for storage and renewable energy sources. Inertial issues, because inertia become a very important target. So inertia issues of renewable energy resources with stochastic behavior, optimal mix, siting and sizing of energy storage of various level of network, electric vehicle, V2G, G2V and V2H, and then energy storage system for meeting transient and other requirements. I think you may also explore the collaboration with those industries, because they could see that, Accenture, ABB, E-Meter, Infosys, IBM, Siemens, Relevant, PowerGrid, SCL, Cisco, um, GE, and okay, almost everyone in this world is currently working on smart grid. Okay, so I think that's all. Thank you very much for your wonderful attention. So we had a very soft and short conclusion lecture for all of you, and thank you very much to carry a good memory and a cool feeling that the smart grid seems to be very tough, but ended and started very smoothly. Thank you very much. Bye bye for now.
So, any query? Sir, 18 minutes.
So they will be coming here? Okay. All right. So we can take up some questions if they have, or some informal discussion can happen,
Yes. So, any questions from your side, please? You may ask.
I think today's, I think we've come to an end, so we can have an informal discussion. I think what we can do, can we allow everyone and switch on their videos and tell them to mute, so that we are preparing for the validity. So सबको open करा दीजिए. सबको you can tell all of them to switch on their videos if they're comfortable.
Yes. Yeah, please make your videos on. विनीत सबको बोल लेता हूँ सर, फिनिश हो गया अब.
Yeah.
So all of you are welcome to ask questions, please. Also, make your video on so it may be more interactive. Today you have not last chance, I should say, but yeah, great opportunity to directly, interact with sir. So very rare opportunity you have.
I think I could see Ajay Kumar, Ajit,
So please turn on your video and you interact with sir. It's a wonderful opportunity for all of us.
I think all of you can just interact. Any questions, any surprises, anything that is really disturbing you for a very long time, what to do, what not to do. Even, kind of the direction for your research for future, or I think you can just open up your voice.
Sir, namaste, sir. Hello, sir. Hello.
I think if you are comfortable.
Sir, मैं पूछता हूँ.
Yeah, you can start
Intelligent
with
grid and smart grid and normal grid. So
what are these?
one is intelligent grid. It is said that everything is going smooth. So some blackouts are there. So what is the means extra need of this? What is extra in this smart grid out of intelligent grid? Both are synonyms or different?
Actually, we do have a conventional grid, okay, excluding transmission grid or distribution grid. They are all conventional grids, okay. But to
हाँ तो के बाद दवा ढूंढ रहा मैं जाऊँ तो भाग जाओ तो मम्मी कहता है कि तुम ना मारो तो मैं ढूंढ के लाऊं मम्मी आधा पौन घंटा तो ऐसे ही ना कि पागल बनाया रो ऐसे घूमत रही सामने लग चली गई तो निकल गया
अच्छा उन्हें पता था कि ऊपर है.
मेरी तो रजाई दे
अच्छा.
के बहुत मार गई थी चुपचाप बचाई फिर मम्मी पहले सीढ़ी हुआ करती थी मेरा जीना नहीं था
हाँ.
तो पीछे उसको सीढ़ी खड़ी करी और मुझे तारे लाई और मैं क्या ये तो डर रहा हूँ
so we missed all the discussions. Okay. So we did very okay. Suman Sharma is saying very insightful. I think we were talking about what is a smart distribution system and a conventional distribution system, and we realized that any system which is capable of returning back to its originality after facing a fault or serious technical challenges will be called as a smart distribution system. Otherwise, it is known as a conventional distribution system. Yeah. Good. And I think, okay, I think, yeah, they're right. They're all slowly.
Sir, hello.
So today we are also declaring some sort of examination. Please. Aye. How are you, Bennett?
Any other questions, please ask.
Maybe you all can switch on your videos, so probably I switch on your videos, isn't it? Yeah. All our guests, I think today we came to an end. And you'll be happy to know that, Namaskar, almost the strength remained 50 from
55
beginning to
plus.
end.
That's
I mean, the consistency, almost everyone, I think everyone actually joined very, kind of continuous way. And yeah, all right. Very good. Kalpana, what's Kalpesh, sir, while doing work on, the message, can you read it out? What is saying?
Sir, while work on DC microgrid protection, what is the role of control? Is it need to consider?
I could see that. Okay. So it's saying that, sir, while doing work on DC microgrid protection, what is the role of control? Is it a need to consider? You see, protection is altogether a new concept, as you know, and DC protection is more challenging, compared to AC protection, because first of all, industries were not mentally prepared to have protection devices for DC grids, because the complete system happened to be AC. But the control pairs actually goes along with DC microgrid. So it is nothing like, a control for a protection, but DC microgrid control and protection, they go together actually back to back. So if you have a DC system, you need to have DC control also, isn't it? Otherwise, how do you balance your generation and load? Am I right? And one more question is coming, research direction, what it says. Very insightful session today with research directions. Thanks, sir. Kindly share on Canvas, sir. Thanks and regards. Okay. I mean, all the problems you can use it, sir. The whole program was awesome and very much informative. Can you please highlight few main challenges in implementation of smart grid technology in Indian energy distribution? Okay. So first of all, one of the common challenge, as I do feel, is about the costing of the lab. Okay, you need to have good investments to create a smart grid laboratory. That is quite challenging. It is not like day-to-day availability in the laboratory. If you are looking for a smart grid lab, then probably you need to invest a reasonably good amount of money. That is number one. But even if you do not have a huge facility like RTDS, with a budget of even 1 to 2 crores investment, you can have actually low cost simulators, and the hardware setup actually is reasonable. That is as like early days, your converters, your PVs, your wind, there is no issue. But only the simulator part actually is costly. So you need to engage with actually low simulators, or you can collaborate with the nearest institution of the country where people had actually simulators. For example, if when someone comes to my lab with a good idea, I do not mind running your simulation and giving you some fantastic results out of it. Yeah. Sir, in spite of smart grid and technology advancement, basic problems of electricity failure in rural areas and tier 3 cities is not yet solved. What is the solution to a very good question? I think the question is, even with too much of technological development, why do we experience power cut? But one thing I will tell you, Prashant, the issue is actually we do experience power cut, but it is not as severe or common as it was. Okay. Whereas you'll be surprised when we were young childs or young kids, we used to have actually almost 60 to 70 days continuous power cut.
Yes, sir.
In evening, actually 1 to 2 hours. Am I right? Especially, middle towns and rural areas. So that problem is, I mean, there's nothing to do with smart grid here, because maintenance aspect actually, currently, if a transformer is getting rust or a cable is getting disconnected, that is due to the way actually we do maintain our systems and the contingency of your transformer substations. So probably I'm very sure that the system is improving, but as you are correct, that it is not yet completely solved. So probably we need to now focus on actually reliability studies as well as maintenance, proper maintenance mechanism to low voltage networks. Okay, that is quite important.
Yes, sir. Yes, sir.
Rajendra, what is saying? Thank you so much, sir. Okay, anything else? Any other suggestions?
Any more questions? You can directly unmute
I think
yourself.
one more. Ajit is writing something. I think you can come up openly. Don't be shy of and running away out of video. You can switch on your video if you are comfortable, please.
You can
Good
directly
good evening,
ask
sir.
questions.
I am
Good evening,
Sahil.
sir. Thank you, sir, for the insightful sessions. And fortunate enough to attend this live session. Earlier, I completed Smart Grid course from SWAYAM. I am from ESL and leading AMI project in Ajmer and Jodhpur discoms. This session helped me widen my knowledge about the subject and would like to attend the future courses on this topic. Okay, thank you very much.
You are invited for advanced course. We will announce it in 2-3.
Yes, sir. I have seen that and would like to attend in person if because I am based in
Sustainability
Jaipur
issues with
only.
smart grid.
So if there is
Sustainability issues with smart grid. Yes, it's certainly actually, I mean, first of all, we are not getting into thermal power plants. We are more or less focusing on actually renewable energy sources. So probably smart grid will certainly make your environment sustainable, no doubt about it. Yeah. Until unless you charge your electric vehicle through a super thermal coal substation, coal thermal power plant. Okay. I think we are close to 6 p.m. I think we can
5 minutes.
5 minutes more to go. Yeah, good.
Sir, I was asking SCADA. Is it
Oh,
part
there is
of
just a minute. There's an interesting question coming up. Recycling of batteries. Oh, very interesting question. So I think this is certainly a cause for all of us concerned. So I mean, recycling of PV panels, recycling of batteries. I think they are certainly going to be issue. There is no doubt about it. We agree, and we have not yet faced that point, but very soon there will be a challenge. So I think recycling of batteries for lead acid is fine, but for lithium, I don't think so. If the battery is out, then my mobile is out, am I right? So I think we need to come out with some good solutions for recycling. Yeah. Thank you. I think some question, Manmohan, please.
Sir, SCADA, is it part of main grid also? No? Earlier it was in practice,
No,
or it
no,
is
no.
new term
It
with
was-
smart grid only?
It is part of smart grid only. SCADA is not a very common feature. MNIT Jaipur had no SCADA. You have a SCADA, I don't know. You have a SCADA system in place?
At one
I
room it is there when we go in SCADA room. I don't know why it is
No,
written
so
there.
probably some advanced metering infrastructure will be there and some data fetched actually about the load generation.
When we go to Acharya Bhavan, one room is there near Tanki water tanks. It is written SCADA room. I was also not quite.
No, probably there must be a mini data collection room actually. So supervisory control.
That's why they have.
So data, so SCADA, mini SCADA room actually. But the SCADA system is also equally very, very expensive, where in one go you can see the complete current voltage profile of the whole system or whole distribution system. Yeah. So this is part of smart grid initiative only. Though the concept was there, but that was not been placed everywhere. Now, instead of 100 SCADA system in Rajasthan, today we have, let's say, 10,000 SCADA systems, something like that. Yeah.
Thank you. Any questions from your side?
Subhrakamalji, namaskar. And good evening. I'm taking a lecture and from 7 o'clock I'm free and then I'll get up. Yeah. Thank you. Thank you. Yeah. Bye. Bye. Bye.
So those people, other CL.
I think the first day we had someone from Patna exactly, and I think Patna.
From 6 p.m.
Sir, currently is use of AI is done in smart grid. I think people have started applying, though the advanced, you see, forecasting tools, for an example. If you're applying ML to PV forecasting and embed it to a smart distribution system, so it is AI application to smart grid. And all your control mechanisms today is ML based actually, So that means AI is always there within the smart grid, no doubt about it.
Earlier we were using other type of control, PLCs, SCADA and everything. Now they are moving towards several system or IoT and other things. So how difficult is to switch from some controller to other controller on the scale of?
Actually, cyber physical system is a different thing. It is not for control, you know. So cyber physical system is basically for cyber threat. Am I right? So if the basic conventional control system is always in place, and it has to be remain in place also. It cannot be replaced. Yeah. Cyber physical is another layer that you add to make your system more smarter, but it is not going to replace your conventional control mechanism. For an example, for example, my PV inverter control, am I right? That I cannot replace by anything. It has to be there. If I have a DFIG machine and its control tool, it has to be there forever. That cannot be replaced or.
Is that critical?
The conventional control system will be there always. For example, there is a cable distribution system cable, no? Can I replace because it is a smart grid? Can I do wireless energy transfer? Okay. So similar to that, the control aspect will be always there in the system. Like your substation transformer, they're physical devices. They cannot be replaced. Please keep your video on if possible. Or you are putting on. All right, I think we can start the conclusion remark now. Many people have joined. I'm happy that many senior people have joined this course. That's quite motivating. Yeah. Good.
Good evening, everyone. Respected Professor MP Patil, Chairman ACT Academy and Director MNIT Jaipur, and also the Principal Coordinator and Instructor of this course, Professor Vinod Sir, Chief Investigator, AICT MNIT Jaipur, Dr. Satyasai Jagannath Nanda Sir, Coordinator AICT Academy MNIT Jaipur, Chief Coordinators, Chief Investigators of AICT Academy, IIT Roorkee, IIT Jabalpur and NIT Patna, and co-coordinators of this FDP from IIT Roorkee, IIT Jabalpur and NIT Patna, and dear participants. It is with immense pleasure that we welcome you all to the valedictory ceremony of the Faculty Development Program on Fundamentals of Smart Grid, jointly organized under the aegis of the Electronics and ICT, that is AICT Academy, MNIT Jaipur, IIT Roorkee, IIT Jabalpur and NIT Patna. Over the last past 1 month, we have explored a comprehensive range of topics, from fundamentals to advanced, of smart grid under the expert guidance of Sir. So, various topics were covered in those 40 hours lectures. So I briefed just we have discussed. Sir has discussed about distributed energy resources, which includes PV, wind, diesel, generators, and grids also. Distributed energy storage systems, which includes batteries, ultra capacitors, battery management systems, and operation and control of AC microgrid, DC microgrid, and hybrid microgrids. Then we have discussed about PMU also, phasor measurement units, and cyber security and resilience in smart grids, demand side management, demand response analysis, and much more. The most attracting part and most significantly, we all have witnessed the live demonstration of cutting-edge experimental setups, including the latest PHIL, Power Hardware in Loop technologies, that is RTDS and Opal RT systems. So this FDP has undoubtedly broadened our understanding of smart grid technologies. Personally, I have learned immensely from this session, and I believe all participants will agree that the course was deeply enriching. all that despite such very hectic schedule and various administrative engagements, Sir has always prioritized to conduct his lectures on time and postponing all his other assignments. So he has always prioritized this. On some occasions, we have seen that because I am here, so person was not having good health on some occasions. Still, he could not deny that or postpone the course. Even on Saturday and Sunday, maybe 2 weeks, 2 3 weeks, sir continuously 7 days conducted the course so that it can be completed in time. So we are very much thankful to sir. Now I request Professor Vinit Sobola sir that please give a token of appreciation to sir.
Thank you. Thank you. I think I have to add so that yeah, that's right. So yes. That's okay. Okay, done. That's right. Thank you. Thank you.
Now I request Professor Vinit Sobola sir to kindly speak few words, share few words about ICT Academy at its future.
Good evening, and Professor Padi Sahab, Professor Ujha, Director of IITDM Jabalpur and Head of Jabalpur Academy, Dr. Manmohan Garg, coordinator of this program, running a marathon, Dr. Nanda, who is our faculty colleague and GICT Academy coordinator, all the participants, where we have seen many industry people and senior people also attending there. I think it's heartening to see you all here, and it is very gratifying for us that our efforts are being fructified. I will start with thanking Professor N.B. Padi Sahab for various ways and roles he is playing, and we are learning from him. The very recent is the way he has shown leading by acting, and he has run a marathon course single-handedly, which is an achievement for our academy because this is only second or third course which a single instructor has run for the whole program. Thank you very much, sir. Of course, he is the chairman of the ICT Academy, and we have seen many changes, and you have been feeling the way we are organizing the program. It is all due to his guidance, his motivation, and the kind of trust he keeps on us. We have been able to reach to this kind of milestone here, and along with our other academies' support, these joint programs are running very well that way. Professor Padi Sahab has just apprised us way back that he has videoed also that he has many courses on SWAYAM platform. He has an ample experience of online delivery, and being a director of 2 institutes and a BOG chairman and a hefty schedule, his kind of agreeing to this program was kind of a proof and evidence that teaching is very close to his heart. We again thank him for various roles he is actually motivating us, guiding us, and leading us. Thanks, Professor Ocha and other CIs of academies for joining this program. And I hope all participants would have definitely benefited. And if you are eager to go with him, our esteemed speaker in the second program of advanced features of smart grid, which is again
Sir, we cannot hear you, sir. For last 1 minute, your voice is not audible, sir. Mr. Sahula, can you hear me? I cannot hear you.
Sir, your voice is not audible.
Yes, now we can hear you.
सर आपके वाले का वो म्यूट था क्या? हाँ? आपके वाले में म्यूट था क्या आपका विवेक? कोई बात नहीं। अभी तक तो मैडम को
Now we can hear you. Thank you. Just for last maybe couple of seconds. I think 1
Madam,
minute.
you are not audible, madam.
इसमें हम लोग ऑडिबल है पर यहाँ पे हमको नहीं सुनाएंगे तो या तो आप अपनी सिस्टम से ऑन करो यस
Can anyone hear me? Yeah, I'm sorry.
मैम आपका तो वॉइस क्लियर है।
हाँ, we can like
You're audible.
other parties.
Go ahead. Yeah. Yes, please, audible. Thank you, ma'am.
Let me write to them. Am I supposed to speak or I don't know?
Madam, please go ahead.
Okay.
Thank you very much for it.
Okay, so thank you so very much for inviting me to this valedictory function. This way I could meet virtually Professor Padi, whom I admire as one of the greatest teachers. I remember, Professor Sahula, our first program, NKN Mode, on AI and deep learning, we were running. That was the first program. And I requested Professor Padi to give a course of lectures on neural network. And he very kindly agreed. And from there, our journey started on AI and deep long back. So that was our first experience.
Thank you very much. Yes, great memory.
And so we are so fortunate, sir, that you have taken out time for this course. And I'm sure that all the participants are greatly benefited. And we look forward to many more such courses where your contribution can be there and where MNIT Jaipur can have a course of lecture by a single faculty. So we will definitely be part of such courses, which are very useful for the research and development in the field. Thank you so very much for making us a part of the program. On behalf of myself and Dr. Sachin Kumar Jain, we thank you once again. Thank you.
Thank you very much, madam, for your kind words. And I think it is our privilege that your academy is always, and we both are joining the same programs usually, and we are getting good speakers and participants that way. I think benefit of participants. I think I was not audible initially. Let me introduce Professor Oja sir. I'm sorry, madam, I was not audible earlier. Professor Oja is the ex-director of Tripartite in Jabalpur and currently chief investigator of AICTE Academy at Jabalpur. Thank you very much, madam. Dr. Sachin, if you are there.
Actually, I tried finding him. I don't know whether he's here or not.
No problem.
Sachin Jain.
Professor MBC?
Because he has some constraint of his meal is at this time only. Yeah.
Okay.
Before dawn, before like sunset.
Yeah. Thank you. Yeah, we are privileged to have you, madam. Thank you.
पहले सर क्या करवाना Now I humbly request sir to share a few words with us and enlighten us with his thoughts and guidance. Over to you, sir.
First of all, thank you very much because all the participants, I am very sure 5 to 7 is not necessarily to be a comfortable hour for any one of us to attend classes. But as a whole, I could see without fail, most of you have attended during 5 to 7 p.m., almost 100% attendance and quite interactive session. Probably I could see whenever I ask just to give a pause where my voice is audible, I could see 20 yes, So that is how actually the class happened to be interesting. And you have actually driven me to come to this point. And today, perhaps I feel like as though today is my last, not only lecture, but last working day sort of feeling because I'm coming to, missing you people from tomorrow. And otherwise, 4:45, there's an alarm that, okay, I have to take the class today. I talk about lectures actually from morning to evening almost for last 20 days. So once again, thank you very much for making me active for last 20 days through lecturing and interactive sessions. I wish to also thank those 4 wonderful volunteers, those who have actually 2 research scholars of Manmohan and 2 students of mine. These 4 were actually continuously here to make sure that the program is successful. A special thank to Manmohan, and he made sure at 7 o'clock he will come with 50-page PPTs that need to be taught next day. So he used to following me like anyway, to make sure that the program is successful and being completed in time. Otherwise, with my responsibility, it's not easy to spare 40 hours in 20 days' time. It's next to impossible. But once again, I thank Dr. Nanda. A special thank to Professor Binit, who also kind of, kind of motivator to make sure that this program is going to end successfully. And once again, thank you all for your patient listening and participation, and looking forward to see you again and again at MNIT Jaipur campus, if possible, in person. Thank you.
Thank you, sir. So now we are open to have the feedback from participants. So some of you are requested to unmute yourself and please provide your feedback on the course. Share your learning, please. Voluntarily, you can start one by one, please.
Very popular in early days. 1989.
So let me then choose. Chandrasekhar ji, are you there? Yes, madam, unmute कीजिए आपको.
So good evening,
Please
sir. I
unmute.
am Dr. R. Zahira from Crescent Institute of Science and Technology, Chennai.
Oh, sorry.
I have already attended this course in NPTEL also, but while attending in the live session, it is very interactive, and also while seeing the hardwares in the live, so we don't have that much research facilities like yours. So it is very much useful. It is an interactive session, and it will be very useful if you are conducting any further session for simulation, especially for simulations, advanced simulations. So it will be very useful for us. So even we are experienced, so we are new to the smart grid. So we have not studied in our academics when we are studying. So it is very useful session, sir.
Thank you. And we will try to explore the possibility of having a short duration, giving them in-hand experience on simulation, if possible. Yeah, thank you.
Okay, thank you.
Thank you, Jaira ma'am. Yes, Chandrasekhar sir, please.
Sir, good evening, sir. It was a very interactive one, and I think I must thank Pacha sir for his. I think what I no words to say. I think really very enthusiastic and energetic at this age. Really, hats off to you, sir. And I think the workshop has the FDP has gone very well, even though it was new to me. It was very interactive. How many sessions I have attended? So all the sessions were very interactive, and all of a sudden I just asked for live demo. I think they have immediately sanctioned for going to NIT Rourkela and then started. So it was very informative, and I all of us have seen that big components, all new to our almost all Bangalore side colleges. So overall, I think this is superb, sir. And what my suggestion is that we want the grid, smart grid, how it works, and it must be a live session, and it must give the work to the participants to demonstrate one by one. So that will be more interactive, because at that time what happens, we work, and then we can have the results at each bay or each side of the feeder, what happens, and we can tell the students also what happens to the battery side. Main is the battery, which is the heart there. So what happens there, and even the PV cells, how much each particular PV array will give the output. So each and every parameter, it's will be calculated thoroughly, and I think that will be more beneficial for the coming up researchers, rather than we almost all. I think we have saturated in that field. But while Sir has started, and even Dr. Manmohan Sir, who has given a little bit inspiration from the previous Power Electronics one, modeling one. From there, I think the journey has been started. I think any journey from Manmohan Sarji, I think I will be a number one participant in that case. In that case, really, I think he must be a driving force for all the participants, sir. Even Sarji also, he hasn't left, because he, as sir told, that he has to tell that this much slides has to be completed next day. So even the for participants also is good, and even for the those who are there also, that's also very good, sir. Sorry, sir, I was actually driving from the college, so I haven't. But it was there in the earphone. I was hearing, and now he has come. I just giving the feedback. But on the whole, superb, sir. Really, I enjoyed the lecture, what it has been given from sir. Thanks a lot, sir.
Yeah, thank you, Chandrasekhar. Because I still remember, whenever there is a question, if no participant responds, the only answer will be from Chandrasekhar. So I think always he's very active, proactive, and Chandrasekhar also made the session more, kind of positive, lively. Thank you, Chandrasekhar, once again. Yeah.
Thanks a lot, sir.
Yes. So, so you have to, yeah. So thank you so much. Actually, I'm just starting my research, and Smart Grid was a very new concept for me, and you taught it from the scratch. And it's so difficult concept was very easily understood by us, and it was like a class, a live class. And it in entire 1 month, it never seems that you are a director. It only seems that you are a teacher and we are students listening to you. So, sir, it was very good, very interactive and very insightful, sir. Thank you so much.
Sir, I would like to say that. Sir, I would like to say. Yeah, so I would like to say that I was very much type of scared from smart grid technologies and how to do research in this field. Now, since I'm read your papers and saw your videos, I'm very much comfortable in this technology, and I can move further in this research field. Thank you, sir.
Sir, can I ask one question, sir?
Go ahead.
Sir, can you suggest some areas what you have taught for the past 1 month where the research can be provoked and we can publish some papers in Q2, Q1, Q3 journals? Thrust point, or we can say that punchline there, where you can write target there.
Very common area agent today is not only renewable integrated smart grid, but also electric EV integrated smart grid seems to be the future agent today. So I suggest almost all the candidates to explore both the hardware implementation as well as simulation aspects of electric vehicle integrated distribution system or a smart distribution system seems to be the future for next couple of years. Thank you.
Thank you, sir. Yeah, so ma'am, you were speaking, actually, you were not audible. Can you please again share your views?
She's not audible.
Still, we are not able to hear you, please.
I think she's to correct her mic.
Not audible, ma'am. Neha, आवाज आ रही है? So ma'am, you are not audible. No, still we are not able to hear. Can you please check your microphones once?
Maybe check out and join.
Okay, or you can write in chat box also if possible. And not audible, ma'am. Not yet. So you can once log out, then log in maybe, then it may help.
Sir, this is Devchandra Singh. May I?
Yes, please. Yes, please continue.
Yeah, myself, Devchandra Singh. I am from Northeastern Regional Institute of Science and Technology, Arunachal Pradesh. Thank you so much. I would like to give my sincere thanks to the organizer for conducting such a well-structured and enriching program. Sir, each module was thoroughly designed and offered a comprehensive understanding for smart grid system and energy storage, and as well as the microgrid concepts were very well explained. And the real-time demonstration of the PHIL and all those hardware that we may have never got an opportunity to see, sir, has very well explained with the help of video, as well as when the video was not clear, sir has very well explained the whole doubts that we were having in our mind. Sir, a very special note of appreciation to Professor N.P. Pathi, sir, for delivering the sessions with such clarity and depth. Thank you so much, sir. And sir, your expertise and engaging teaching style really enhance our learning experience, particularly in our translating the complex concepts into practical insights. Thanks a lot, sir. Sir, actually, to be frank, sir, I have been teaching smart grid technologies in my college, in my MTech course in the power system engineering, and I have been following your SWAYAM NPTEL course since 2017. The course was first introduced by myself in our institute, and I have been following since then your the very first course. Now it has been changed to basics to advanced. Earlier it was introduction to smart grid, sir, if I remember correctly, sir. Premlata madam and yourself were contributed those courses, and that really helped us, sir. And today when we see you online, it has enriched our actually learning. So I have been teaching, but my experience is very less in this field. But after this particular training program, it has very much enriched, sir. Thanks a lot for that, sir. And in the future, if any such kind of program is there, I will never miss this opportunity, sir. And in fact, I personally want to meet you also someday, like MNIT Jaipur. I had once visited when there was a conference in the year 2018, in the month of December. But next time, sir, surely if any conference is there, I will surely come down and will like to surely meet with you also. This program has been truly insightful and will significantly contribute to our academic and professional growth in the domain of smart grid and energy system. Thanks a lot, sir. Thank you so much from this far corner of the country, sir. Thanks, sir. Thank you, sir.
Thank you, Devchandra Sameji. I think we will see to that actually how best we can promote, science and engineering through online mode, which can
Yes,
reach to each and every corner of this country.
definitely, sir.
And let us look forward to meet you in person when you visit to Jaipur next time. Thank you.
Yes, sir. Thank you. Thank you so much.
आपको बोलूं? Good evening to everyone. I am Shailendra Pandey. I am in MTech second year, and I feel very lucky that Professor N.P. Padi is my supervisor. So a lot have already everyone has told about the course, how brilliant it was. So I'm not going into that. Actually, it was very brilliant, and I would just like to share a few things about my story. The first day when I was joined here, so I thought it would be very boring, and I never wanted to come honestly. But just in few lines, I would like to say that after that day, I never forced myself to come here. I came here every day in time around 4:15 or 4:30, and I got very motivated from sir. And in due course, he also gave me good clarity about what should I do in my research work also. Thank you, sir. And I would like to thank you all the sir, Neha ma'am and Vivek sir, and special thanks to Manmohan sir also. Thank you, sir.
Thank you.
So thank you everyone. So now let me have the vote of thanks for this entire FDP. So we started on 7th of July. Today is 6th of August. So entirely 1 month we are completing. So we know on the day one, the course started from, it was supposed to be started from airport, but yeah, so sir was out of station that day, but we actually requested sir that if you are not here, we can postpone it for next day. Then sir said no, all the participants they are uh, waiting for this course, and if we postpone suddenly, then it will not be good. So wherever I will be there, I will start on the same time which we have already committed to them. So we started on that. So this entire 1 month was very much enriching and engaged for us, and lots of learning for personally to me. So as we come to end, once again, I take this opportunity on the behalf of all the EICT academies. I extend our sincere gratitude to Sir for delivering such insightful, well-structured and inspiring lecture to our participants. More than 100 participants registered for this course, and as Sir has personally told that about 55, on average 55 to 60 participants were regular during old age. So during all these 20 days, all the participants enthusiastically attended the lectures and participated in thought-provoking discussion and insightful questions. We thank each one of you for your active involvement in this FDP. We hope that this program has enriched your knowledge and equipped you with new tools and perspectives to take forward into your institutions. We deeply appreciate the support and guidance received from the EICT Academy MNIT Jaipur, especially Professor Vince Saula sir. So sir was always, continuously connecting with me and always asking how the course is going on. Do you need any help from me or any kind of things are required? Please let me know. So we are very much thankful to you, sir, for helping us for a smooth conduction of the course. I'm thankful to all the chief investigators and co-coordinators of this course from other EICT academies for jointly organizing this successful FDP and helping us with registrations and encouraging participants to join the course on a regular basis, and thus contributing to overall success of this FDP. I also want to take this opportunity to appreciate the technical staff, Geeta ji and Mr. Ramesh, and research scholars, especially Prashant at IIT Roorkee, and who defended thesis, submitted thesis, who submitted the thesis, and research scholars from MNIT Jaipur, Neha, Anupam, Vivek, and Salendra, who have worked diligently over the past month to ensure this program is conducted smoothly. With the end, but rather the beginning of new phase, a phase where we continue to explore, experiment, and evolve. Let us stay connected, share our progress, and support one another as we implement what we have learned. Once again, thank you all for making this FDP a success. I wish you all the very best in your academic and professional endeavors. Stay curious, stay inspired, stay connected to Admire Live IT Roorkee. Thank you very much.
Thank you. And before we conclude, one small story actually, I mean, it's very interesting. Many of you may not be aware. Like, when you see a movie comes to an end, we see the kind of recording challenges they display. So similarly, there is a story behind it, which is one day actually I'm supposed to travel, that I took a class in the entrance gate of the airport. That many one of you may not be knowing. So the flight happened to be at such a time A, and I entered to the airport actually 4 hours early to make sure that I clear the security and be there in the gate and taking class. The whole airport is surprising what is happening to this gentleman. He's teaching for 2 hours. So once I was traveling and taking a lecture at first, that was the thing. So I think kind of the team in this fight really worked very hard. So special thanks to all of them, and including one more actually, and looking forward to similar kind of support. And thank you very much. Bye-bye.
So please stay tuned to our. You type in Google Admire Live IT Roorkee, so you will be having couple of courses, NPTEL courses, which sir has already informed us. You can register those courses. Also, we will have one more course, EICT sponsored course. Maybe we will publish the date soon. So website for, and in this group also I will inform, and we will send emails, and it will be there in websites. We have more courses on which is conducted by EICT Academy MNIT Jaipur. So you please regularly visit, and whatever course you like and falls in your domain, you can easily join and attend the sessions. We have a variety of courses and a variety of speakers across the countries from industry, academics, and all. Thank you very much. So once again, now tomorrow there will be no class at 5 p.m. Anyway, as sir already spoke that in many classes, maybe some of you are not asking questions, but if you feel any questions, any doubt later on, this material is with you, then you can write email to me, and I will discuss with sir and respond to you. So thank you. We end over here. Thank you, madam, for joining us. Oja, ma'am.
Thank you, sir. Thank you. Thank you,
All
sir.
the best in your future endeavors.
Thank you. Thank you, sir. Thank you. Good.